Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve a question from mechanics, and this question belongs to paper 9709/41 for the session October November 24. And we are going to solve the final question of this paper, which is a car has mass 1200 kg. When the car is traveling at a speed of v meter per second, there is a resistive force of magnitude kV Newton. The maximum power of the car's engine is 92.16 kilowatt. The car travels along a straight level road. The car has a greatest possible constant speed of 48 meter per second. Show that k equal to 40. Well, this question is a question on kinematics, and we are going to apply the concept of the most widely used concept in physics, which is motion law of Newton. So let's start our solution. As the car is traveling along a straight level road, so let it be straight level road, direction is horizontal, and we know the concept we are going to apply is the motion law of Newton. Driving force minus resistance force equal to mass into acceleration. Well, what is the driving force here? Driving force, the formula of driving force is power over velocity minus resistance force is also here fixed. This is magnitude of kVn. This is the constant resistive force, means frictional force. And weight can be dissolved. If you want to use weight, that can also be used. If you want to use that weight as mg sine 0 degree, then constant resistive force is kv. Kv is equal to mass into acceleration. As the car is traveling at a constant speed, so it doesn't have any acceleration, that means product is zero. So power over velocity, power is given as 92.16 kilowatt, so 92,160 watt over velocity. Maximum velocity is 48 over 48 minus mg sine 0. Sine 0 is equal to 0, though this in most of the cases we avoid writing this so that you don't get confused. I have written weight is not negligible, weight is there, but as it produces 0 as the quantity, that's why it is avoided or not written. It doesn't mean that weight is not playing role. Weight must be calculated both in horizontal or vertical ways. Well, so k is to be obtained, and velocity, maximum velocity is 48. So 48 k is equal to 0. Well, after that, if we simplify more, we are going to get, or if we divide 9216 by 48, it is going to be, let it not be divide here, 92160 over 48 is equal to 48k. If we make k as subject, then k is equal to 92160 over 48 over 48, 48 into 48, 48 into 48. So if we divide 92160 by 48 into 48, it is going to be 40. So they have told us to show that our k is 40. We have shown. We can write here the notation of shown. Well, and this may be the final step. So if k is 40, finally our resistive force, that means frictional force, is 40 into velocity. Well, let's move on to the next question. The next question says, at an instant when its speed is 45 meter per second, find the greatest possible acceleration of the car. Same concept of the motion law of Newton we are going to apply, and it is still moving on a horizontal road. So driving force minus resistance force is equal to mass into acceleration. Well, so driving force is what we have already calculated, P over V, minus resistance forces, it was kV. Look at this, kV. What is the resistance force? It is kV. So K stands for 40, we have already obtained. So 40 V, it will be 40 V, 40 V equal to mass into acceleration. Mass of the car is 1200 kg, so 1200 A. Well, now value of power, it was 92160. Velocity is given here. Velocity is 45 meter per second. So it is 45 minus 40 into 45, because velocity is given 45 equal to 1200 A. So if we divide 92160 by 45, it is going to be 2048. 2048 minus, if we multiply 4 by 45, it is going to be 180. So 1800 equal to 1200 A. 1200 A. Hence our acceleration is from 1248. If we subtract 1800, it's 248. 248 will be divided by 1200. Hence our acceleration is going to be, let it be divided, 248. 248 divided by 1.207 meter per second square is the final answer. So these two parts of the solution are very simple to understand, and you know how to solve this. You yourself are capable of solving this, I believe that. Well, that's all about this first two parts of the solution. Let's move on to the third part. What does the third part say? Third part says, third part says the car now travels at a constant speed up a hill inclined at an angle of sine inverse of 0.15 to the horizontal. Find the greatest possible speed of the car going up the hill. Well, we are going to apply the same concept, but before that we will have to draw the diagram. Let me draw the diagram somewhere. Yes. Here we can draw the diagram. Suppose this is the hill and this is horizontal ground. Okay. After that, here is the car which is moving up. Okay. Then this is weight. This is weight. Weight always acts vertically downward, perpendicularly downward. Then this is normal reaction. It should not be so much larger. It may be joined from here. Well, so this one is the 90-degree. Okay. After that, I think if I erase this portion, it will be better for you to understand. Let me erase this part, is not necessary for us. So if I join, well, here is the, this is our weight acting downward, and here is the theta. Well, this is the scenario of the diagram. Well, the system is at this point. Now we are going to apply the concept of the motion law of Newton. Well, let's start our writing. Yes, we can continue writing over here. Okay. If we start our writing, the car is now traveling a hill. Okay. So the direction will be like this. Then the concept is same concept, driving force minus resistance force is equal to mass into acceleration. So what is the driving force here? Driving force, we have used repeatedly this formula P over V, and we know that constant resistance to motion was 40 V. Okay, 40 V minus, there should be one more resistance force over here, which is, we should not ignore weight. Remember, weight should not be ignored. Well, so what is weight here? What is the resistance causing to motion? It is mg sin theta, because you know sin theta equal to, look, here the car now travels at a constant speed. Speed is constant, so there is no acceleration, means right side is 0. Now mg sin theta, how did we define this, that it should be sin theta? Look at this, the car was moving to that direction. Okay, and definitely, we are calculating this horizontal axis in term of horizontal axis in term of the plane or hill, but in term of the triangle, this is now a vertical line. If you look at this right angle triangle, this is vertical line. So vertical line is equal to mg sin theta. I think you have understood, because this vertical line of this triangle is parallel to the line of, that means ground of the hill. Okay, so power is given 92160, because it's all about maximum, and maximum power is, if you look at this, maximum power given is what, 90. Yes, here it is given maximum power is 92.16 kilowatt always, as we are finding maximum acceleration or maximum speed, so we'll have to use the maximum power. Okay, so maximum power is 92160, and velocity is to be obtained. So V minus 40 V minus mass of the car was 1200 into acceleration due to gravity is 10, and sin theta is given as 0.15 equal to 0, equal to, it is going to be 0, right side is 0. Well, after that, if we keep on calculating, this is going to be 40V. Look, it's not only 40. K was 40, so we should not avoid V. It should be 40V. Yes, 40V. 40V. Then it is going to be 92160 over V minus 40V minus, if you multiply, it is going to be zero point 0.5, the 1.5 into 1200, so it is 1800 actually. 1800 equal to 0. Then if we simplify this, it is going to be V over 92160 minus 40V square, 40V squared minus 1800V, 1800V v equal to 0. So if we do cross multiplication, it is going to be, what is it going to be? Only numerator will remain there. I think all the zeros can be dissolved. If we dissolve the zeros, then there remains 4. If we divide this by 4, so negative symbol will go away. It is v square. And if we divide 180 by 4, it is 145. 45 v, and minus, the symbol will be interchanged. It is going to be minus if we divide 92 by 423, and if we divide 16 by 4, it is going to be 04 equal to 0. Now we are going to apply the quadratic formula. B is equal to, negative 45. As look at this, we are finding speed, and for speed can never be negative. Speed is scalar term, so we will have to once again, let me show you that they have told us to find what, find the greatest possible speed. Speed can never be negative. Speed is scalar term, so it should not be negative. Already b is negative, so it will be positive square root over v square. So 45 squared minus plus, plus 4 into AC. A is 1, C is 2, 304. Well, hence our V is going to be, its denominator is 2A. So A is 1. Hence our V is going to be, let us do this calculation. So negative 45, negative 45 30.5 equal to 30.5 meter per second is our final answer. They have told us to find constant speed. We have found that the constant speed is 30.5 meter per second when the car was traveling a hill. I mean sliding or moving up a hill. So that's all about the solution to question number 7. These are the first two parts of the same question, and the final part is this one. So thank you all for being with me. May Allah bless us all with beneficial knowledge and the knowledge which is for the welfare of the whole humankind. Fi amanillah.